Hello everyone, welcome to Augmented Technology Private Limited. Today I am excited to introduce our one of the product, that is 4DI3DO4AI2AOM. That is 4 channel digital input, 3 channel digital output, 4 channel analog input and 2 channel analog output, which is communicating with the RS485, that is Modbus. Here we have the model. In this model, here we have the power supply configuration, and here we have the RS485 for the communication purpose. In this power supply, we have provided the configuration as a positive and negative, where you can provide up to 24 volt DC in any direction. Here we used the bridge rectifier, which supports the board for the reverse connection also. In this RS485 communication, here we have the configuration as a A and B, A for the positive, B for the negative. You can connect with the RS485 cable with the PC to get the data. And here we have the deep switch part. In this deep switch part, where user can set their own slave ID and the baud rates. For the baud rate part, here in the board they have mentioned already. And for the slave IDs, where user can set up to 31 slave IDs. And here we have the reset part. Whenever user changing the slave ID and the baud rates, on that time just need to press the reset button. So the board will get configured with the new addresses. And here we have the DI part, that is 4DI, which is operated through the optocouplers, which supports up to 80 volt. Here you can connect relays, switches, sensors. Here we have the AI part, that is 4AI part. In this AI, here we have the jumper part. Here we have the AI part. For this AI, here we have the jumper selections. Whenever you need to set for the AI, on that time all jumpers should be in a AI configuration. Whenever you are using the NTC part, on that time you can shift the jumper from AI to NTC. Just by shifting the jumper, the AI part will work as a NTC. And in this for AI, we have the provision also for voltage. We have the 5 volt and 10 volt provision here for the jumpers. Whenever the AI you are using, on that time you can shift the jumpers for the voltage reference. And here we have the DO part, which is 3DO, operated through the relays. And here we have the AO part, that is a 2AO. For the next step, we will focus on the testing procedure. Please concentrate on the testing procedures and ignore the board visuals which is provided in the video. In this video, we will only know about how to connect the power supply and how to connect the RS485 with the Modbus cable. Okay, here we have the power supply part. There we have mentioned in the board, that is positive and negative. Connect the power supply with the positive and the negative and provide the power supply. See here the LED turn on, that means power supply has provided properly. Then get to know how to connect the RS485 cable. Here we have provided the configuration as the B, that is for negative. Here I have connected the negative. A for the positive, I have connected the positive wire. So then connect this wire with the PC. Okay, this is the RS485 cable. So I am connecting this with the PC. Now we will connect the RS485 cable with the PC. So I have connected with the PC. Now open the device manager. In the device manager, go to the port here, that is showing as the COM6. That means I am using the port number 6 for the serial communication. So then go to the Modbus pole, click on connection, connect the board and select the port and click on OK. See, the board has connected properly. After proper connections, here you will get the RX and TX LED blinking continuously. That means RS485 communicating with the PC properly. In this video part, we will get to know how to configure the slave IDs and the baud rates. So here we have the slave ID and the baud rates. So by default, that is the 9600 baud rate and the slave ID will be a 1. So now we will go with the PC. See here the board has connected properly with the default baud rate and the slave IDs. So now I need to change the slave ID as the 3. Okay, before changing the slave IDs, here this is the dip switch for the slave ID. So here in the dip switch they have mentioned 1, 2, 3, 4. That means the slave ID configuration has a 1, 2, 4, 8. That means if I need the slave ID 3, then I need to hide first and the second pin. That means 1 plus 2, that will be a 3 slave IDs. Okay, then I need the baud rate as a 19200. So the first pin that is mentioned in the board, that is 19200. So I will hide this pin. Now I need to press the reset. So the board will get for the new configuration. See, here I will get the timeout error. Whenever you will get the timeout error, disconnect the board and connect the board with the new configuration. The baud rate as 19200 and the slave ID will be a 3. Okay, see, after connecting this, here the TX has continuous increasing. That means the board has connected with the new slave ID and the baud rate. So now I need to set the slave ID as the 5 and the baud rate will be a 38400. So now I will hide the first pin slave ID and the third pin slave ID. That means 4 plus 1, that will be a 5. Now I will need to set the baud rate, that is 38400. That is the second pin. So I will hide this pin and now I will press the reset. See, here I will get the timeout error. Do the same thing, disconnect the board and connect the board with the new configuration. The baud rate will be a 38400. Okay, then the slave ID will be a 5. See, here the board has connected properly with the new configurations as a slave ID 5 and the baud rate 38400. So now I need to set the baud rate as the 57600 and the slave ID will be a 15. So if I need the slave ID as the 15, then I need to hide the all slave ID pins. That will be a 15. Okay, now I need to set the baud rate, that is for the 57600. Okay, now I need to press the reset button. Here I will get the timeout error. Then disconnect the board and connect the board with the new baud rate and the slave ID. Here the baud rate 57600 and the slave ID will be a 15. See, the board has connected properly with the new slave ID and the baud rate. Now I need to set the slave ID as the same and the new baud rate, that is 15200. See, okay, 15200, that is the new baud rate. Just press the reset, disconnect the board and connect the board with the new baud rate, that is 15200. Click OK. See, the board has connected properly because I have put the slave ID 15 as same and the only change, that is baud rate. Now I need to get back all these with the default. So load the all pins. Okay, otherwise you can set only first pin as a high for the slave ID, otherwise you can low, there is no issue. Now press the reset. The board has gone for the default slave ID and the baud rate. So now here I will get the timeout error. Disconnect the board and connect the board with the default address. Baud rate is a 9600 and the slave ID will be a 1. See, the board is communicating with the properly for the default addresses. Now open the Modbus, go to the connection, connect the board with the port ID and click on OK. See, the board is connected properly. That means here you are getting the RX and TX blinking continuously. That means the RS485 connected properly with the PC. And according to the datasheet, they mentioned the DI registers. Okay, on that mentioned registers you will get the DI values. For the DI we need to take the reference voltage. Here I am taking the reference voltage, that is 12 volt, which is provided in the board, that also mentioned in the DI part. And here I have taken the male to male jumper. Okay, this is the male to male jumper for the DI reference. I have connected with the 12 voltage. This is the 12 voltage reference. So whenever I will short with the DI1, here the LED also turn on for the DI1, and also in Modbus pole I will get the mentioned register value as the high. For the particular register I will get the value as the high, that is 1. I will do with the short with the DI2. See, here also you will get the LED on for the DI2, and also in Modbus for the particular register you will get the value as the 1, that is DI2. And for the DI3 I will do the same. See, here also you will get the LED on. That means in register also you will get the high value 1. For do with the DI4 also, here also the DI4 LED turn on, and also in Modbus pole you will get the value as the high 1. Don't do with the ground, only short with the DI parts except the ground part. Open the Modbus and click on connection. Connect the board with the port number with the serial port, okay, and the all baud rate and the everything will be default. Click on OK. See, here the board connected properly. Here you will get the RX and TX LED blinking with continuously. That means the RS485 communicating proper with the board. Now for the according to the datasheet, the first register will be a DO part. Okay, here we have the 4DO. The starting 4 register will be a DO part, and click on that, provide the value as the high and send the request. Within the second the LED has turned on. That means the DO1 operated properly. And do the same thing for the DO2. Click on that and provide the value on, send the request. Here the DO2 has operated properly. Do the same thing for the DO3. Click on that and provide the value as the high. Then the DO3 operated properly. That means the all DO is operating properly. There is no issue with the DO. Now open the Modbus pole and go to the connection and connect the board with the port number. Click on OK. Then go to the setup and click on read and write and select the function as a 3. Here we need a AI. For that we need a function code 3. Click on OK. See, here the board connected properly. Here also you will getting the RX and TX LED blinking continuously. That means the board has connected properly with the RS485 cable. And for the AI we need a reference as a 5 voltage, which is also we have in the board. Okay, whenever we are checking the AI, if there is a jumpers in the board, please put the all jumpers in the AI part. Okay, then I am taking the reference as the, here I have the 5 volt. Okay, and short with the positive only. Here in the board we have mentioned the polarities positive and negative. Okay, click on the short with the positive. Whenever you short with the positive, you will get the values in the particular mentioned registers. Okay, for AI1, see there is a register mentioned in the Modbus pole. You will get the value as the 1023. That is the resolution. You will get the value. For the AI2, when I short with the 5 voltage, see I will get the resolution value. Same for the AI3, I will get the register value as a 1023 in the mentioned registers. For the AI4 also I will do with the same. There I will get the values in the mentioned registers. According to the datasheet, check once the AI register part. In this part we will get to know how to configure the analog output. For the analog output we need one multimeter to check the voltage. So here I have the, for the 10 bit there is the Modbus register will be starting 4 register will be a 10 bit according to the board, and according to the datasheet you will get the mentioned register in the whatever the analog output is there. According to that resolution you will get the mentioned registers in the datasheet. So according to that datasheet you will get the values. So means 1 2 is the 10 bit. For the analog output 10 bit, here I will provide the 1023, that is a 10 bit resolution. So whenever I provide that 1023, so for the first EO I will get the voltage. So here I will check the voltage. See, for the EO1 I am getting the voltage as 8.14, that means full resolution. So for the here for second I will provide a 512, that means a half resolution. So in AO2 I will get the 4.1 something, that means it's a 10 bit. I provided the value as 512 resolution, that means I will get the half voltage near 5 volt. And for example, now for the AO2 I will provide 1023, so I will get a 8.2, 8.19 or 8.2 something.